Resolve the horizontal resultant force, which is 600 Newton in this case, into components acting along the U and V axis. U and V axis, it doesn't matter the name U and V or X and Y, they all the same. That means we have only two axes, U and V. That means we will have only two components of this force when we decompose it or resolve it into components. And then determine the magnitude of these components. First thing, interpreting the question down mathematically. So what is known to us in this case? So known, we know that is given to us in the question. We have Fr, the resultant force, equal to 600 Newton. We also know that one of the theta from the x-axis equal 30 degrees, and also another theta equal to 30 degrees from the y-axis. So what is needed is finding Fu and Fv. First step in doing that solution, first thing is your free body diagram. In this case, I'm going to draw. Here is one of the axes, which is the V axis, and drawing the U axis, and we also having the force, the resultant force. And we have the Fv along the V axis. Now in order to use the parallelogram law, we have to construct a parallelogram. So parallel to the Fu, we have to draw a line until it meets with the Fr. Same thing, parallel to the Fv, we have to draw a line until it crosses here at this point. Let's call this point here, it's A, and we know that that's Fu, and this one here is going to be Fu dash, and we have Fv, this one here is going to be Fv dash. I know is being given to me this theta here, it's 30 degree, and this one here also is 30 degree. This is pretty much everything. So the first step or the second thing that I will do, numbering all of the thetas inside. Call this theta 1, theta 2, theta 3, theta 4, theta 5, and this one here it's theta 6, and finally theta 7. Now I have theta 1 plus theta 6 plus theta 7, 1, 6, and 7. They all on the same line, therefore they all should equal to 180 degrees. Theta 1 is unknown, which I'm solving for. Theta 6 is 30 degrees, and theta 7 the same as 30 degrees. They all should equal to 180 degrees. Solving for theta 1, So 180 minus 60 degrees equal to 120 degrees. Theta 7 equal to theta 5 equal to 30 degrees. Theta 7 equal to theta 5 as an alternating angle. Also, we have theta 4 plus theta 5 plus theta 6 should equal to 180 degrees. When we add all of the interior angle for the triangle, they all should add to 180 degrees. Theta 6 and theta 5 here in this case are known to me, so I'm going to solve for theta 4. Theta 5, it is 30 degrees. Theta 6 also 30 degrees. And theta 4 should equal to 180 degrees minus 60. So theta 4 should equal to 180 degrees minus 60 degrees. That should be again 120 degrees. At this point, I will use the sine law, which is Fr, which is the resultant force divided by sine theta 5 equal to f v dash over sine theta 6. F Solving for f v dash should equal Fr resultant force multiplied by sine theta 6 divided by sine theta 5. Plug in all of these values and you should get f v dash equal to 600 Newton. We know Fv equal to Fv dash, therefore Fv equal to 600 Newton. Using again the sine law to find Fu, then we can say Fu over sine theta 4 equal Fv dash over sine theta 6, and that all when you solve for Fu, that should equal Fv dash sine theta 4 divided by sine theta 6. Plug in all of these values, you should get Fu equal to 1039 Newton, and this is what is needed from us, finding Fu and Fv.